Within all the factors that consume energy within a building, the HVAC factor is the most important one. The energy consumed for heating, ventilation, and air conditioning of rooms accounts for 50% of the total electricity consumption of buildings and nearly 30% of the total energy consumption. The current technology with buildings is essentially, I would say, quite primitive. They assume that people occupy the building during a certain time, let's say from 9 to 5 or from 8 to 6, and they run occupancy, ventilation, and conditioning of room based on that schedule. The main issue is that there is no feedback into the system to actually try to condition the rooms and the ventilation and adapt based on actual occupancy and actual usage. The technology that we use in order to detect the transition of people inside buildings is essentially wireless sensor network technology. It's a technology that has a board with a small microprocessor. It has an integrated radio, and it has also a micro camera and a PIR sensor. Through many mechanisms and many algorithms for computer vision, we do a lot of local processing in order to essentially count the number of people that are transitioning underneath the camera. We just keep in a central server a count of all the movement of all the balls across all the different buildings in order to get a global estimate of occupancy and a precise estimate of occupancy in each room. The impact of this technology that we're developing here at UC Merced is quite critical because one of the most fundamental problems, as I mentioned before, was that buildings are essentially designed as open-loop systems. From the point of view of an architect or a building designer, there is no feedback about how the design of the building actually impact the operational cost of the building over the next 40 or 50 years this building is being used. And we're trying to change that. This would allow, for instance, an architect or designer to understand that if they design a hallway or a building or a room in a particular way, and this will impact the movement of people in a particular manner, and this also will dramatically affect operational costs and energy usage and comfort of the people. So by integrating our occupancy models with standard tools that architects are familiar with, like AutoCAD or sketching tools, we believe that we are trying to bring science back to the architecture community, something that currently it's not there.